So this lesson is going to be about the properties of logarithms and solving equations dealing with logs and exponents. So take a quick look at the different properties. They're really similar to the exponential properties. If you need to pause it right here, you can. But I'm going to go ahead and talk about two new properties, and they're called the inverse properties. And they come from where we know that f of x equals log base b of x and g of x equal to b of x. We know that these two are inverses. We proved this in class. Exponentials and logarithms are inverses of each other. So because of this, we also know that this property f of g of x and g of f of x, this function composition, when we have inverses, they both equal x. So because of that, I can perform function composition and get my two new properties. So if I do f of g of x, I take the entire function g of x, which in this case is b of x, and I plug it in for my x variable. So this becomes log base b, and instead of x, I have the entire function g of x. So log base b of b of x. And I know that this equals x because they are inverses. Next we do g of f of x, which means I take the entire f of x function and plug it in for the x and g. So I get b raised to, instead of the x power, I have it raised to the entire function f of x. So log base b of x. And because I know they are inverses, I know this equals x. So you can kind of think of this as these canceling out, and all you're left with is x. This cancels, and all you're left with is x. If you want to think of it that way, that's fine. Just remember that this is the inverse properties, and we're going to be using these a lot. So let's do a couple examples of these logs, and then we'll look at the inverse properties. So first example is multiplication, so I can split this up. This becomes log base 2 of 4 plus log base 2 of 16. I know log base 2 of 4, that's 2 to some number equals 4. Well, 2 to the second equals 4. And this means that 2 to some number equals 16. Well, 2 to the 4th power equals 16, so my answer is 6. Next is the exponent property. This tells me I can take this exponent and move it in front. So this becomes 3 times log base 2 of 4. Well, I know log base 2 of 4 is 2. I just figured that out. So it's 3 times 2, which equals 6. There are other ways to do these problems applying the laws of logarithms. There is no one more correct way. There's all different kinds of ways. So as long as you get to the correct answer, it doesn't matter which path you take. Here we have the natural log of 1 over e cubed. Remember that the natural log is log base e. So I have log base e of 1 over e cubed. You don't have to write log base e, but I just write it so you can remember that natural log is log base e. So now I can split this up using my division properties, or my quotient properties. This is going to be log base e of 1 minus log base e of e to the third. Well, log base e of 1, this follows my property where any base of 1 is 0. And then this is my inverse property. Log base e of e, they cancel. You can think of it like that. And I'm just left with 3. So my answer is -3. Next, we're going to look at the change of base formula. You use this whenever you can't plug in something like log base 2 of 7 into your calculator. You actually have to plug in using log base 10. And you can also change the base to get it to maybe a base that you want to work with. So I can take this log base 2 of 7 and I can rewrite it using any base b. As long as it's log base b of the number I'm originally taking the log of over log base b of my original base. So I can plug in any base that I want. So I would like to use base 10 because that's the most common, it's easiest to work with. So this becomes log base 10 remember when we have log base 10, we don't write the base, of 7 over log base 10 of 2. And you can plug this into your calculator and get the answer. So if I plug this into my calculator, I get log base 7 over log base 2, hit enter, and my answer is 2.81. We'll round to 2 decimal places. So 2.81 is my answer. Next, we're going to move on to solving equations. If you feel like I'm going too fast, please pause the video, rewind. If it's not going fast enough for you, you can skip ahead. That's okay. So first, we're going to look at solving equations by equating exponents. And what I mean by that is we know that if we have two numbers raised to a power, two of the same bases, for instance, raised to like 2 squared equals 2, well, obviously, the only way for these to be equal is to have my x also equal to 2. So in this case, my x will be 2. The bases are the same. Bases are equal. That means the exponents also have to be equal. So I'm going to use that for these equating exponents questions. So first, I want to get these to have the same base. Well, I know 25 is 5 squared and 125 is 5 cubed. So I'm going to rewrite these with a base of 5. So this is 5 squared raised to the x minus 1 power. And this is 5 cubed raised to the 4x power. So I'm going to apply the power property. This becomes 5. I have to distribute this 2. So 5 to the entire quantity here, 2x minus 2, equals 5. 3 times 4 is 12, so 12x. My bases are the same, so now I can make my exponents equal to each other. So 2x minus 2 equals 12x. You can subtract 2x from both sides and then divide by 10. So x equals negative 1/5. Next, we're going to look at the same thing. Sorry about the high-pitched dogs. Now you see why I try to do these when nobody is home, and also why it takes me so long to upload them. So next, we're going to look at simplifying this base. I want to get each of these bases to 4. I could simplify them down to 2, but if I can get to 4, why do extra work when you don't need to? So I'm going to rewrite 64 as 4 cubed, and that's going to be raised to the x plus 2 power. So now I have 4 to the x minus 1 equals 4, and I need to distribute this 3. Multiplying, I'm doing my power property, so this is 3x plus 6. The bases are the same. That means my exponents are equal. So x minus 1 equals 3x plus 6. I solve for x, so I can add 1 to both sides and subtract 3x from both sides. So I get negative 2x equals 7. Divide by negative 2, I get x equals negative 7/2. Alright, so next we're going to look at solving equations by taking the log of both sides. It might seem crazy, but just like you can divide both sides by 2 or square both sides or take the square root of both sides of the equation, as long as you do the same thing to both sides of the equation, it really doesn't matter what you do. We're going to be using our inverse properties here, so you need to keep those in mind. That is to say that log base b of b to the x equals x, and b raised to the log base b of x power also equals x. So we're going to apply the first property right here by taking the log of both sides. So if you see in my property, I have a number raised to the x power, and here I have a number raised to the x power. Well, in order to get rid of that, I need to take the log of this base of both sides. So I'm going to do log base 3 of 3 to the x. And whenever I do the one side, I have to do the other. So log base 3 of 14. Now this is my inverse property. So you can think of these as canceling out. So I'm just left with the x there. So this is x equals log base 3 of 14. Now I don't have the ability to put log base 3 of 14 in my calculator, so I have to do the change of base formula and make it log 14 over log 3. So my answer is 2.402. Some of you said you wanted a cameo for my son. We just got it. Okay, so the next problem, we're going to try and get this e to the x right here by itself, just like it was a variable. So we're always trying to isolate the variable. So the first thing we're going to do is add 9 to both sides. So I get negative 5 e to the x. I'm sorry, subtract 9 from both sides. So we get negative 5 e to negative 5 e to the x equals negative 3. Divide both sides by negative 5, so we get e to the x equals positive 3/5. Now we can take the log base e of both sides, but that's the same thing. Remember, log base e is the same thing as natural log. So I can take the natural log of both sides, and these cancel, and you're left with x equals the natural log of 3/5. If you plug the natural log of 3/5 into the calculator, natural log of 3/5, you get negative. So your answer is x equals negative 0.511. So x equals negative 0.511. Next one, look at a little bit more complicated because it's abstract, but exponentiating both sides, and that just means making both sides an exponent. Again, like I said, as long as you do it to both sides, you can pretty much do whatever you want. The first one, however, we can kind of go back to our laws of logarithms, and we can match it up with our exponent rule that we talked about, where we had 2 to some number, like 2 equals 2 to the x. What does x have to be? And it has to be 2 because our bases are the same, our exponents have to be the same. The same thing applies for logarithms. If our bases are the same, then what we're taking the log of has to also be the same if these two things are equal. So because these two things are equal, I'm left with 2x plus 15 equals 3x. So subtract 2x from both sides, you get 15 equals x. And that's the short way to do it. To show you that it works by exponentiating both sides, I'll come back to this problem after we do number 2. So look at number 2. I've got 16 natural log of x equals 30. I want to get the natural log of x by itself. So I divide both sides by 16. Well, this simplifies into 15 over 8. So I have the natural log of x equals 15 over 8. Now I want to get rid of this x, so I'm going to have to make this my exponent. I'm using my property b raised to the log base b of x power equals x. That's the property that I'm using. Well, remember, natural log of x is the same thing as log base e of x. So if I'm going to make this log base e of x, I need this base right here to also be e. So this is going to be e to the natural log of x power equals e to the 15 over 8 power. And this is called exponentiating both sides. You're making each side an exponent. So these cancel, and I'm left with x equals e to the 15/8. And we can plug this into our calculator. If you go second natural log, it's got e to some number, and we want our number to be 15 over 8. I think it was 15 over 8. Yep, 15 over 8. So our answer is 6.52. So x equals 6.52. Now if we go back to our first example, I'm going to show you how to exponentiate both sides here. So we want to exponentiate and make this whole thing an exponent. So I'm going to have some number raised, change colors, some number raised to the log base 5 of 2x plus 15 power equals some number raised to the log base 5 of 3x. Well, that number is 5. So I have 5 raised to this power, 5 raised to this power. These cancel, and I'm back where I started with 2x plus 15 equal to 3x, so x equals 15.